We now have a goal in mind. The goal is to create JavaScript applications that actually work in all browsers but still use cutting-edge features. To get that done, we're going to be using a tool, and that tool is called Babel. That's B-A-B-E-L. Babel is going to take our JavaScript code and convert it to something that all browsers understand. So if we use a fancy cutting-edge feature when we're writing our script, Babel is going to convert that to a dumber feature that all browsers understand, and that's what's actually going to run behind the scenes. This still allows us to work with and write code using the cutting-edge features, but our application will work pretty much everywhere. So let's go ahead and kick this video off by messing around with this tool in the browser. Then we're actually going to integrate it into our application. To start off, let's crack open a new tab, and we're going to go to babel.js.io. Now, when you view this page, you're going to get hit with a lot of information. There are a ton of various doc pages here showing you how you can configure and set it up. Don't worry, we're going to cover that in the videos. The reason I'm bringing you here is to go to this page right here, the Try It Out page. The Try It Out page is where we're going to be able to see what Babel would do for our local code, but in the browser, so we don't have to install anything to figure out exactly what it does. Once we figure out what it does and see that it's useful, we can actually integrate it into our code. Now, you might see this page with the configuration open. You can leave all of those at their default value. We don't have to worry about that. On the left-hand side is the code that we would write. We then pass that code through Babel, and on the right-hand side is the code that comes out. Now, the first thing we'll notice is that use strict is automatically added to all files. This is great. It means that when we're writing code, we don't have to actually add that in and remember it. Babel can add it in for us. Let's go ahead and start off with a simple example. On the left-hand side, we're going to provide our code. So I'm just going to use console.log to print a string right here, the string gen. And when I do that on the right-hand side, we pretty much get our code completely unchanged. I have the same code here as I have here. The only difference is that a semicolon was added on to the end for us by Babel. Now in this case, nothing's really changing because console.log is a well-supported feature. Babel doesn't need to change that. It's already going to work everywhere anyways. Let's go ahead and switch things up a little bit and use a feature that Babel will actually change. What we're going to do is create a const. So const name equals gen. Then I'm going to reference the name variable as opposed to providing a string in line. Now in this case, we're going to have the same functionality, but on the right-hand side, we can see the code has indeed changed. Const went to var. So const is a newer feature not supported in older browser versions. We still want to be able to take advantage of const in our code, but we also want our app to work in a wide range of browsers. With Babel converting things behind the scenes, that is exactly what we get. Now, this doesn't mean we can abuse the rules of those features. For example, if I try to redeclare name, something I can't do, we're going to see an error gets thrown. Down below, duplicate declaration name. We are trying to redeclare name, which is not allowed. So in this case, we actually get no output code. It's only when we have valid code like this do we actually see the compiled result. Now let's go ahead and actually explore one more feature where we're going to see a much more significant change. What we're going to do is create a really simple dummy class. I'm going to create a class called Hangman like we did for the Hangman game, and I'm not even going to add any methods inside of it. With this empty class in place, we can now see the output on the right-hand side where the class definition no longer exists. Instead, we have a significant amount of additional code added. Up above, we have a method for internal use by Babel to make sure that our class code still works, called class call check. Down below, we have a Hangman function created instead, and this uses that method to set things up. The functionality for both files is the same. The only difference is that this one is easier for us to write, so we're going to write it, and this run is easier for the browser to run, so this is what the browser is going to run. Now, we don't have to worry about being able to read or understand the code over here. This is compiled code, not meant to be read or edited by the user. If we want to change how the program works, we don't change this, we change this. So let's go ahead and add one additional feature. I'm going to add a method onto the class. My method, I'll set it up, and I'll have it return a string. Testing, for example. On the right-hand side, we can see that to get this method to work, we have a significant amount of additional code added. We now have a create class function that gets used down below, and we can see that inside of our Hangman function, we have calls to class call check and create class where we set up the method. Once again, we don't need to understand how this code works. The purpose of pulling both of these up is to see exactly what Babel does. Babel takes code we write with the latest features, and it compiles it down into more simple code that older browsers can understand. This is exactly what we're going to be setting up, and that's what I want to do next. To actually be able to perform this conversion process with files locally on our machine, we're going to have to install Babel as a command line tool. So we're going to install it just like we installed Live Server earlier in the course. That means we'll be switching over to the terminal and running a single command to get all of this done. We'll be using npm like we did previously. If you remember, we used npm install. Then we're going to provide the -g flag. This allows us to install the module globally and get access to a new set of commands from the command line so we can use the tool. Then the module name. This one is called Babel-CLI, which stands for the Babel command line interface. This is the version of Babel that lets us run commands from the terminal. After the module name, we can use the @ sign and specify the specific version we want. Let's use 6.26.0, which is the latest version. Now, if I go ahead and run this command, it's actually going to go through the installation process. And once it's done, all I want to do is verify that things actually installed correctly by running a test command. Right here, we're going to run Babel space --version. All this is going to do is print the version of Babel currently installed. If we get a version, we know things installed correctly. If we get some sort of error message, we know things did not install correctly. Here I am indeed getting version 6.26.0, which is great. If you got an error message saying something along the lines of command not found, that means that the installation command did not work successfully, and you can just crack open a new question in the course Q&A, and I'll work with you to get unstuck and back on track. All right, we now have Babel installed on our computers, and we're going to move over to Visual Studio Code and actually create an input file that we can run through Babel. For the moment, we're going to work in a brand new directory inside of JS Bootcamp, though don't worry, we'll be integrating what we learn about Babel into our applications, the Hangman, Notes, and To-Do app. For now, though, let's make a new directory inside of JS Bootcamp, and all we're going to do is call this directory something like boilerplate. We'll make a little boilerplate project that has all of these tools set up, so we don't have to manually configure them each time we want to start a new web app. Then inside of boilerplate, I'm going to add a brand new file. This file can be called whatever we like. I'm going to call it input.js. So this is the code that we're going to put through Babel. And all I want to put inside of here is the exact same stuff we had over inside of Babel in the browser. So I'm going to take this code, I'm going to copy it, and I'm going to paste it inside of input.js. Now that we have our input file, we can go ahead and actually pass this through Babel. So we can go back to the terminal, use clear to clear the terminal output, and all I'm going to do is take a moment to change directories using cd and go into that boilerplate folder. From here, we can now use the Babel command to process the input.js file. The command that we're going to run needs two pieces of information. It needs to know what file we're trying to use as the input, what we have on the left-hand side in the browser, and it needs to know where we want to save the output, what we had on the right-hand side in the browser. We have to provide both of these with the command. So let's go ahead and start with Babel. The first thing we provide is the name of the file that we want to use as the input. Now I called that one input.js, so we just provide that right here. The next thing we have to do is provide the output file name. This file is a file that doesn't exist. The Babel command is actually going to create it. We do this by providing the O flag, then after O and a space, we give a name to that output file. To keep things simple, I'm just going to call this one output.js. So this command is going to read the contents of input.js, it's going to run it through Babel, and it is going to dump the output into output.js. Let's go ahead and run the command and see what happens. What happens? Well, nothing prints. We simply see that we go back to the command line. This means that things went well, and if I switch over to Visual Studio Code, we can see there's a brand new file in the boilerplate directory. This is the output from Babel. If I crack that file open, what do we see? We see that almost nothing was changed. We still have const, we still have the class definition. The only difference between the two is that our input file doesn't have semicolons and the output file does. Nothing's been converted. We're not seeing all of that weird output code. The problem here is that we've run Babel, but we haven't specified any of the Babel plugins we want to use. By default, Babel does almost nothing. If we actually want to convert const and class and the other ES6 and ES7 features, which we do, we have to set up just one more thing. What we're going to be installing is called a Babel preset. This is what's going to give us the functionality that we actually saw from Babel over inside of the browser. So that's going to make sure Babel actually converts those ES6 and ES7 features down into regular, boring old JavaScript that older browsers can understand. To install this preset, we're not going to be installing it as a global NPM module. Instead, we're going to be installing it as a local NPM module, local to our project, local to the boilerplate directory. Now, we're going to be using local modules quite a bit in this section, so I want to take our time going through this process. The first thing we have to do is set up the boilerplate project to actually be able to install local modules. And to do this, we just need to run a single command from the terminal. The command is called npm init. Now, it's important to make sure we run this command from the boilerplate folder. I don't want to run it from JS Bootcamp, and I wouldn't want to run it from any folder inside of boilerplate. You want to run npm init from the root of your project. Now, this command doesn't do anything crazy. It's just going to ask you a few questions about your project. We're going to use all of the default values since the values don't matter. Then it is going to create a single new file in the project, and we'll crack that open in the terminal and see exactly what we get. So right here, we're going to run the command, and it is going to ask us for about 7 or 8 pieces of information. We're not going to provide any of them. So the first thing is package name. We don't have to provide a package name. It just uses our folder name by default. Make sure that you don't use spaces in your package name should you choose to change it. I'm going to hit enter to accept the default value. We also have the current version of our project. We can leave it at 1.0. I'll hit enter to accept that. We have a description. I'm not going to provide that at all. We have an entry point, which we're also not going to be using. So we can just hit enter to use the default there. We have a test command, a get repository, keywords, author, and a license. We're going to hit enter through all of those. Now, the only thing it's going to do is write a file. And right here at the end, it is asking for your permission to create the following file. Here it's creating a file called package.json in the boilerplate folder, and the contents it's going to put inside of there are the contents we see right here, with the various key value pairs. For name, we picked boilerplate. For description, we picked nothing. So it's asking us if this is okay. All we have to do is hit yes, hit enter, and now we're done. Our project is initialized, and if we head over to Visual Studio Code, we can actually see we have that brand new package.json file. If we crack that open, all we have inside of there is the stuff that the command said it would put inside of there. We have a simple JSON file with some basic configuration. We're going to be using this in just a moment to store the various dependencies our project needs, one of them being that preset that we're going to use for Babel. Let's go ahead and take things back to the terminal and run another installation command to install something locally. I'm going to use clear to clear up the terminal output. This one is going to look very similar to how we installed Babel CLI, just without that global flag. So npm install. Then right here, we provide the module name. This one is called Babel -preset -env. Then we can provide the @ symbol to provide the version we want. Let's go ahead and use 1.6.1, which is the latest. And you'll notice that what I'm not doing here is I am not providing the G flag. We don't want to install this globally. We want to install it locally for our project. When we go ahead and run this command, it is still going to install the module. But instead of giving us a new command from the command line, it's going to take the module code and it is going to dump it in a new directory in the root of our project. This one is called node modules. This is where the installed code lives. This folder contains the module that we just installed. It is not a folder we're ever going to be diving into, and you shouldn't change any of the code inside of there. We can crack it open for a moment just to see what lives inside of there, and it is essentially a long set of directories. Here we have our module that we installed, as well as its dependencies. You can just pick a random folder and crack it open and see that there are more files and folders inside of there. So this is all of the code necessary to get the env preset up and running. We were able to get all of it by installing the module. We also notice that inside of package.json, we now have that module listed in a new property called dependencies. We have the module name and we have the version that we're currently depending on. We also have one brand new file called package-lock.json. This just keeps track of the version of modules we're using to make sure we don't run into any conflicts later on. You should never change anything in node modules. You should never manually change anything in package-lock.json either. We are going to be making some changes to package.json throughout the course, and that is perfectly fine. Now, if all of this seems a bit confusing, don't worry. We're going to get a lot more experience with all of this as we move through the section. For now, we have that new module installed, and all I want to do is wrap this video up by rerunning that Babel command, but telling it to use our brand new preset. From the terminal, let's go ahead and clear the output using the clear command. Then we're going to have that previous command set up. So it was Babel with our input.js file. We then used O to set up the output file. You could have also used -out-file. Both of those are identical. The one is just a shorthand for the other. So right here, the out file is output.js. Then we're going to provide one more thing. So another space. This one is -presets. And the spelling for that one is important. A lot of students usually mess that up. And right after presets, we're just going to provide the one preset we want to use, the one we just installed called env. You don't have to provide the Babel-preset part of the module name as seen here. All you have to do is give Babel the last piece. Now we can actually go ahead and run our command. I'm going to run the program, and once again, we're not going to see anything in the terminal. But if we check out the file in output.js, what do we get? We get exactly what we had over inside of the browser. This is a modified version of our file that's going to work in a wider range of browsers. So as we're creating our web applications, we're going to write code like this. We're then going to run it through Babel, and when we actually link a script file to our index.html, we're going to be linking in this file, not this one. And that's where I'd like to stop for this one. We now have Babel set up locally on our machine. In the next couple of videos, we're going to continue learning about this tool and others. I'm really excited to continue on building out the boilerplate project. So let's go ahead and jump in to the next one.